G'day everyone and welcome back to the channel. So yesterday and today I've spent, or the majority of yesterday and today I've spent organising basically my component decisions, so component values and also the type of component. Mainly the type of component is what I've spent the most time on, you know, like reading ESR values and the inductance of resistors and choosing capacitor types, you know, for other reasons like the breakdown properties and stuff like that, you know, all the little intricacies of everything. And so I've made a few changes, not too many. I've taken notes of stuff as I've been going. So just try and ignore what's written here because half of it applies to the power supply, not the output section, and it won't make any sense looking at it. Basically everything under here, so that, like where I've got noted base R for base resistors, 2.2 R/CF and 10 R/CF quarter watt. I've added 2.2 ohm base resistors. See, I've already got mistakes myself. I'll just pause the video whilst I fix that up. It doesn't matter. Only take a second. Anyway, the quarter watt, I've written half a watt here. I'm going to change that. All right. Okay, so the base resistors I've chosen, the reason I've gone with quarter watt, well, I don't currently have any half watt or, I've got 1 watt, but that's just overkill really. But the main reason I've gone with carbon film over metal film, I mean, inductance isn't really a problem at this low of a resistance because there's not going to be much inductance to it, but still carbon film beats metal film here. And the other main reason is going with quarter watt, it makes basically fusible resistors. So if something goes really sour with a transistor, obviously the amp's still screwed anyway, right? But the quicker everything stops going up in smoke, the better, right? So yeah, that's my logic for that. The 2 watt, you know, I'll just look at my notes first because I think I've noted everything down as I've changed it. Oh yeah, right, in the Zobel network, the capacitor, the 10 ohm resistors, I've changed these also to, well, can't even remember what I ended up putting in here. Yes, these I went and changed to quarter watt carbon film too because I had half watt metal film. Okay. Right, smaller. Oh my god, I just realised what I did there on that bottom one. 0.5 watt, 0.25 watt. That doesn't make much sense now, does it? Right. Okay, so that's the changes I made in terms of base resistors. I'm trying to find my eraser. I just threw it on the floor and it's just disappeared into oblivion. Okay, I found it. Right. So base resistors 2.2 ohm, driver base resistors 10 ohms, and like I said, all quarter watt carbon film. Gotta just screwed that up. So the next thing I changed was the capacitor here in the Zobel network. It's now 100 nano, 250 volt poly cap. When I say poly, I mean like a mylar poly. Like, show you the difference and why I chose it. I don't want it to get warm from current flowing through it. So I've gone with a 250 volt one for the Zobel network. This is just a 100 volt one. This is the cap that is right there, this 100 nano. But for the Zobel, I've gone bigger with this. I've got a few different types of capacitors that I've been thinking about using, but each have their own caveats. You know, you've got self-healing capacitors, which the problem is every time there's a little spike on them or whatever, they can what do you call it? You know, they can diminish their capacity. So I don't know if that would really happen in this situation anyway, probably not, but Anyway, I think that will be fine. The 100-volt one will probably work, but I feel more comfortable with that just due to the size, the thickness of the dielectric inside, everything. It's built, it's just a lot better for the job of dissipating power. Incidentally, the resistors that I've used for the little Bougero cell, whatever you want to call it, Zabel network, they're 47 ohm metal oxide film. They're metal oxide film, and sorry, everything on the floor today. These 120 ohm resistors and these 10 ohm resistors, some 560 ohm resistors. I wouldn't mind making them also, what do you call it, carbon film. I might end up doing that. The 560s in the bias string here, and the 120s are here, so I already changed the 33Ks also to, you know what, I'm just going to pause the video because I'm noticing that I did 2 lots of changing, and I haven't noted down my second lot of changes that I made. So to avoid doing this through the video, I'm just going to pause the camera and just quickly go over this. One moment, please. Okay, so I spent a little bit of time going over this, and now I've got everything how it should be. So my apologies. So, like I was saying, 2.2 ohm quarter watt carbon film for base resistors here, and 10 ohm quarter watt carbon film for the base resistors here. 200 ohm resistors, again carbon film, 1 watt each here to get the 2 watt dissipation. Now, coming back down here, actually I've just spotted something else I want to change to. One moment, sorry, my apologies. Alright, well I was just looking at that resistor there thinking I want to change that to carbon film, but the only carbon film I have in 820 ohm are 1 watt. The thing is, I feel like a quarter watt is too small for that resistor. But I feel like 1 watt's too much, but I don't have half watt in carbon film. So I think for now, because it's under a K, the rule I'm trying to keep with this is everything, honestly, within a couple hundred ohms, but if it, worst case scenario, under a K, I'm trying to keep, everything above a K, should I say, or a few hundred ohms to a K. I'm trying to keep carbon film, and everything that's, say, like this resistor here that's on the capacitor that's got the audio signal coming into it, the discharge resistor for it. I don't want anything inductive there, or where the audio signal's present. So for now, I'm just going to leave that as a metal film. It's only 820 ohms. It shouldn't, I don't know, it might be on the edge of being too inductive. We'll see. We'll see. I'm just going to put these 820s back in the drawer. So even when you've got literally a whole room full of components, you still don't have enough. And I literally have a room full of components, and I still can't find everything I want for every project, Anyway, so I'll just leave that. So what I have changed is I've put carbon film quarter watt for the 33Ks, because 33Ks on a metal film's gonna, I just don't want inductance there. I've noted down that these 2 points go to that bias string just so people know what those 2 places are. Alright, back to my notes, because I've noted down other changes that I've made. So we've gone over the resistors, the capacitor in the Zabel network, the Mylar, poly, whatever you want to call it. Yep. The 3.3 microhenry inductor, I've changed that to 2.2 microhenries. It's going to be around 6 turns. No, it's going to be way more than that. What was I thinking? I've done inverse math. I hope everyone gets that one. Inverse math. I'll work that out later. Anyway, it's going to be 2.2 microhenries. I will fill in this little space here with the actual amount of turns when I wrap it. Okay. Oh yeah, and the diodes, I didn't note that down. The diodes in the bias string, I'm pretty sure BY229s, let me get the data sheet, 1 second. Oh, I didn't have the data sheet on my computer, but it's right here in this old J-Car catalogue. BY229's a fast diode, so I'm pretty sure they're faster than Schottkys, but I could be wrong. Actually, no, I think I am wrong, because the Schottky's probably going to be a lot faster due to its small junction. Yeah. Anyway, they're definitely a lot faster than regular diodes. So I've put UF4 007s here and here instead of 1N4 007s, but for the reverse diode, it's just a 1N4 007. I know that's not a very big difference, but I'm just going over everything I've changed. 47, what does that say? God, can't even read my own writing. I think that's going to be an R. What's that for? 47U plus 100N. Ah, right. 47, yes, right here. The 47 microfarad electrolytic, I've added 100 nano film capacitor to that. When I say film capacitor, because this is going to be sitting across a 126 volt. I just realised what I've written on here for the rail voltages. Jeez, that'd be spicy. Actually, I intend on building an amplifier with rail voltages that high for higher impedance speakers soon, but no, not this one. This is for 4 ohm loads and yeah, about 250 watts RMS per channel. To be quite honest with you, I think it's going to be somewhere around 50 volts, the transformers I'm using. By the time it's rectified, I think they're about 45, 48. By the time it's rectified, it'll probably be about 55 volts. Yeah, so anyway, plus or minus 55. There's around about 100 volts across the rail, so I've gone for a 400 volt film cap. I could use 100, but it's just too close, you know. I don't believe in that sort of crap. What else have I added? Yeah, I've already gone over the 200 ohm resistor getting changed for the two 100 ohm resistors. That's partly for heat dissipation and partly for stability. I don't want the inductance of the metal films in there. Oh yes, it's not 10 turn, it's 25. I changed the offset pots to 25 turn. The bias pot down here it is. The bias pot's still just 1 turn. And yes, the diodes. So that's everything I've changed. Now the other thing I've been looking at is capacitors for the power supply section. I was not able to find the exact specs for those really big 100 volt 10,000 mic ones that I've got, but I was able to find, well, I found a capacitor online that I am almost, when I say almost, I mean 99.999% certain this is the same capacitor that I found in its like actual factory where it's made a lot cheaper, and J-Car and lots of other people buy them and relabel them, or Suntan or whatever company supplied them to J-Car, but anyway. And I found 0.22 ohms for that cap for ESR, and I found another one that was made like by some reputable brand. I can't remember who it was by, but it came out to 0.11. Now, I would like to use them, but they're just way too big, to be honest with you. I really just can't see that happening. So what I'm thinking about doing is piling up a whole load of 4700 mic caps. I'm just looking over here. I thought I had more out. Let me just go and count my inventory. It'll be 1 second. Okay, my apologies. From where I was standing, I was looking over to where I've got stuff everywhere in this lab, as you'll see shortly. I was looking over and it looked like 4 groups of 4 caps, but it's actually 4 groups of 6 caps. So what I've got is I've got 3 4700 mic caps per rail for each amp. So 3 3, 6, 9. Yeah, 3, 6, 9, 12. 24. Total 24 capacitors. No, wait. What am I saying? I don't think sometimes. Let me go recalculate this. I think I've done something wrong with my power supply math. Well, I know what I've done. I thought I had finished and I'd walked off and completely forgotten that I was in the middle of calculating my capacitor value. Because I got up to this part and I started coming up with, how do I explain this? Different ideas. I mean, these will fit in the case, but they take up a lot of room and they've just got a little bit too much voltage headroom for this build. But the other problem I found was the 63 volt 4700 mic caps. The cap, I think it is, has a ripple current rating of 2.5 amps. Now, I was able to find some better caps that go up to 3 amps, but still, that's not very much compared to the 8.1 amp rating that you get on this guy. It's quite big too. I'll just go grab 2 caps just to show you. Actually, I'll grab 3 caps because I've got some 10,000 mic at 63 volt as well. So, just to give you an idea, that's the 100 volt 10,000. That's the 63 volt 10,000. So, you see what I'm saying about ripple current, right? And this is the 4700 mic at 63 volt, right? So, you know, let me go make some decisions. I'll be back in a moment and I'll tell you what I've decided upon. Alright, I've decided. I had worked this out before, but what I did is I started taking capacitors out the drawer, put them on the table in all different groups, and I was thinking about what I was going to use, and then I started putting some 4700 mics down where all my parts are that I've decided I'm going to use. But I didn't finish counting them out and putting the rest of them there, and then I walked out the room and forgot what I was doing. So anyway, I decided to use the 4700 mics, but what I've decided to do is this. So even if they're only 2.5, 3 amps each, you know, there's still 9, 10 amps of ripple current there, or 8 to 10 amps, which is, you know, the same or better than what we had here with the 100 volt 10,000. So I'm going to call that a win because that gives me what? 4, 8, 16 plus 7, 7, 14, 28, 16 plus 28. What have I done wrong? No, 18.8. Yeah, it's almost 1900 microfarads. You know, I would expect to see between 10 and 22,000 mic in an amp of this size. So I'm going to use that. I'm happy with that. For ripple current reasons, for ESR reasons, and for just the actual capacitance value itself, I am going to say that's probably the best out of everything I've got in here that I could choose for this build. So that's what I'm going to do. I'll just go put these down 1 sec. Alright, so that's the power supply capacitors sorted. I'll just bring the phone, take the lock off, and I'll just bring the phone over to where I am over here so that I can give you guys a look. So that's what I've chosen for the 2 power supplies. The bridge rectifiers, incidentally, these huge Chonkin 35 amp bridges. I don't need a 35 amp bridge in here, but anyone that's done a bit of work with electronics will be able to tell you that the smaller the current rating on a bridge is, the more forward voltage drop it'll get under load, and also this is just going to handle up, you know, really well in terms of what do you call it? The really low ESR, high current pulse when you switch it on. So, and I've got plenty of them in my drawer, so I just grabbed a couple of them, you know. These caps, I wouldn't mind being smaller, but I didn't have anything. You know what? I probably do. It's because I wrote bloody 126 volts on each rail. I was thinking I know, you know what? They're going to get made smaller too. I'll go sort that out now. Alright, I didn't have any lower voltage 47 mics, so why on earth is my image like that? One moment. Okay. Sorry about that. I wasn't thinking. I'm standing over here where it's not too dark and I had no light on my phone. The ambient light wasn't enough for the camera, so it was making the image grainy with the auto white balance. Anyway, these will just go in for now. It is what it is. Something else I've noticed was that I had just grabbed my normal metal wire wound resistors out the drawer. So I got these. I think these are supposed to be metal film or something like that. I think they're supposed to be lower inductance than the wire wound ones. We'll test that in a moment, because that's what I ordered them as. These are the capacitors that are coupling the amplifier to the output stage at the moment. They may go away because this might end up with, say, another buffer stage or driver stage, whatever you want to call it, behind the stage that's there at the moment, and then a different topology of amplifier driving it. Well, we'll end up with a different topology of amplifier driving it, like, long tail pair, something like that, with a current source and sink either end of it, So these are probably only temporary, but they're there for now. These are the resistors that are going to be in parallel with the 2.2 ohm air core inductor for the output, the Zabel network. At the moment, all I've got, I'm not going to be using this piece of wire that you see here. That's something else I've changed. This piece of wire is 1.25 millimeters, so it can just join join the wire collection. I've got a bit of a copper wire collection. I'm going to use this. This is the biggest that I've got in here at the moment. This is like 1.5 millimeters, I think. One moment. No clue. I'd say that's 1.5. I know my caliper's flat, but I might be able to get an idea if I just... Awkward doing things with one hand. If I just put it in here and we look, yeah, that's 1.5, maybe even 1.75. Looking at it by eye, no, it's 1.5. So that'll have to do. I wanted to use something a bit bigger, but it is what it is, I'm just gonna have a quick calculation on the wire diameter, and I'll tell you right now if that's going to be a temporary inductor or if I'm just going to stick with the 1.5. I think I'm just going to leave it for now. When we build the amps, I'll crank the shit out of it and I'll fill the inductors. If they're warm, I'll go up to 2 mil. I was going to choose 1.75, but I didn't have 1.75, and that roll is 1.5. That's the biggest I've got in here, so we'll just go with that. Like I said, if it's warm, then I'll have to buy something. It is what it is. What else? So what I've got to do now, I've been building a bag here of parts, so this is everything that's already sorted out, ready. I've got to take these 4 transistors off these 2 boards and add them to this bag. I've got to wind 4 inductors for those networks, and I've got to match transistors. So that's what I'm up to now. I have salvaged a couple of things from, I'll just take the auto lock off. It was already off. I had salvaged a couple of things from those. So those were those were salvaged. Those were salvaged. These were salvaged from the original build that I was doing. I just never, well, not the original build, sorry, should I say the second build. These ones I completely screwed up. So yeah, fuse holders, a couple of things I've salvaged, but all the components that are on the circuit boards, because the legs on them are only like, you know, yay long, I've just decided to go with all new components. And also for things like electrolytic capacitors and stuff like that, because I don't want to build it and then have it fail because of dry caps in a couple of years or something like that. So, you know, so that's where I'm up to at the moment. I think what I'm going to do now is I'm going to take off a few more parts. I wanted to salvage the speaker outputs and the RCA inputs, and this little network for the inputs from those old amps. And then I'm just going to take everything off, clean up the heat sinks. Like I said, take those 4 transistors off these 2 boards, wind my coils, and start matching transistors. So that's where I'm up to now. What I'll do is I'll stop recording. I'll have a look how long this video has gone on for. If it's been a reasonable length, I'll upload it as it is, and I'll do a little bit more work and then make a video on that. If it isn't, you know, very long, I'll do a little bit more in this video. So I'll be back in a minute. Alright, I'm going to fit a bit more in this video, which is good. So I've also noticed that there was something else that I was definitely going to put in this video anyway that I forgot to cover. The power switch is going to have a 10 nanofarad 1 kilovolt disc ceramic across it for arc quenching purposes. The secondary of the transformer, the capacitors that I've chosen to put on that, I swear I just heard something land. I think there's a hole in this bag. Give me a sec. Alright, well there's no hole in this bag, so whatever I heard must have just been 2 components hitting each other in the bag. But anyway, back to this. For the secondary of the transformer output, I've just decided to go with these guys, the 100 volt ones. 100 nanofarad, 100 volt. So the power supply is going to be live coming into a switch. Across that switch will be 10 nano, 1 kV. I'm missing something, aren't I? What am I missing? Oh, the fuse. Haven't decided on the fuse yet. I'll work that out. I'll go work that out now. I'll be back in a moment. Alright, I've done a bit of thinking about this. Quite a bit of thinking. Just plug my phone in. And I've come... It looks a bit dark, doesn't it? Alright. I've come to the conclusion, given the size of the transformers that I've got, I mean, they're literally... I'll grab one and I'll bring it over to here because it'll probably make more sense how big it is when I drop it on this book. That is an A4 sheet of paper. So that's not a small transformer, right? It's almost as big as an A4 sheet of paper. It's freaking massive. The inrush current on that thing, with no load on it, can be up to 3 amps. I already know that. That's not what that 3 amp is there for. That 3 amp is 500 watts at 240 volts plus like little bit of margin is about 3 amps. The transformer's inrush is 3 amps with no load on it. Now, I'm going to have extremely low ESR and about 18, 19, whatever it was, 1,000 microfarads of capacitance on each half of the secondary from, you know, the 0 volt center tap to each outer winding. So the inrush current on it could end up, you know, like 5-10 times that. I don't know what to do about that. I think that the most sensible thing to do is to just stick a 3 or 4 amp slow blow fuse in there and see what happens. Basically, when we build the amp, just see what happens. If it blows, put a big one in there. If it starts getting, you know, towards 10 amps or over 10 amps, then maybe an NTC or some inrush limiting circuitry. I've got a funny feeling that we're going to end up needing something like that because the fuse is probably just going to get out of hand. So I'll just put a little box here with a question mark in it because we might have inrush limiting after the fuse. We might not, and it might just end up, you know, linked over or going straight through. You know what I'm saying. You know, it could be some sort of circuit like a relay that bypasses a resistor or a relay that bypasses an NTC or something like that. It could be just an NTC. Who knows yet, but when we get to it, we'll get to it. I just think it's more sensible to work that out in real life given the situation that we've got here. So back to the rest of the power supply. So we're going to have two 100 nano caps there. Mylar, poly, whatever you know it as. Then that's going to go into our full bridge rectifier. I always manage to screw up drawing bridges. When I say screw it up, I mean I'm not very neat at drawing them, and I always sit there staring at it wishing I did a neater job drawing it. Oh well, all good. Silly way of drawing it, I know. Anyway, then we're going to have our, 6 capacitors, 3 on each side. I'll just bring that out a little bit further. That was a square. I'm the worst person when it comes to drawing. Like, I am really, really messy writing, drawing, and if I'm rushing like this, I'm also standing up, so I'm looking down. I should sit down. I'm trying to watch what I'm doing on the phone like an idiot. So that's what we're going to have, right? That's going to be the power supply basically. So I feel like I'm missing something, eh? Probably just because it's getting late. It's probably just me. Yeah, no, it's just me. So yeah, the other thing that I yet have to do, well, I've still got 2 bits of circuitry that I have to design. I've got to design some current sinks, current sources for this section here. I might not. I haven't thought about that yet. That's why there's a question mark there. But anyhow, I need to work out what I'm going to do with that. And then the preamp section, I still have to design that. It's going to be, you know, a long tail pair with another long tail pair. I forget what you call the two, but, you know, a typical preamp stage, a couple of long tail pairs and some current sinks and sources above and below feeding into this. So I've got to go sort that out. I think what I'm going to do now, because I'm starting with what I've got, as you can probably tell, I think I'm going to get these inductors sorted out and wind them up. Since I've already got the wire here, I might as well just get to it. So I'm going to get them wound up now, and then I'll come back once those are wound and I'll show you what I've got. And then I'm going to start matching the output devices. These transistors that are in this drawer, these are all O category gain, but they're all batch 248. No, they're not fakes, they are legit, and you can tell because the writing's slightly different. They always are. When you get the same batch of these, I've noticed that. So these look quite legit, and I've already done a test of these in another video. I've got enough here, I could smash one of each open if I want. I mean, I've got all of these, which are all batch 248, and then I've got, I have these other ones, which are just random different batches. So there is batch 508 there, and that was 2SC 5200s. These are all 2SA 1943s and 2SC 5200s, by the way. My favourite transistors. Batch 507 1943s. What do we got here? 228. What were they? 5200s. 228 5200s. And 223 1943s. 248 1943s. What are these? 248. There you go. That's more of this batch. Yes, that came from one seller, that came from another seller, that came from another seller, all cheap as chips, and strangely enough, there's part of this batch. There. Go figure. Anyway, I have a lifetime supply of these things. You know, you wouldn't believe this. A couple of years ago, I bought, I can't remember how many, it was a couple of tubes, you know, like, as they come, you know, sometimes components come on the reel, sometimes they come in tubes, and a few other different form factors, but for this size of component I'm talking about. The tubes are about maybe this long, maybe a bit longer actually now I think about it. I'm just trying to think how many that would be. One moment. I know how I can do some rough math on this. I'd say that the tube was about 3 times, a time and a half, like the length of this paper and then another half sheet. If you put it there, I'd say it was about that long. So if I go just over half the sheet, 1, 2, 3, 4, 5, 6, 7, 8. I don't remember buying 30. Maybe I got 50 of each. Maybe it was a bit longer. Anyway, I spent hundreds of dollars on those. I got them from DigiKey. And the reason I spent so much money all those years ago on these was because I wanted them all from the same batch. So it'd be easy for me to match them. And I spent hundreds. And then just recently, I found people on AliExpress selling these by, like, this was one pile I bought, I think. Pretty sure it was. Might have been 2. No, I'm pretty sure that was one order I got. You know, I probably spent like $20, $30 on that. If it was 2, maybe I spent $60 on it. But I mean, that's still not a few $100s, you know, a couple, like 150, 200. I can't remember what I spent. Maybe I spent 300. It was quite a few years ago that I bought them, but wow, did I save a lot of money this time. Not only I saved money, but I've got that many I won't probably have to buy any for the rest of my life. Anyway, I'm sure I'll go through them. Anyway, so that's what I'm going to do now. I'm going to go off and wind those coils, come back, give you a look at them, and then we'll start matching these transistors. I've got this here so we can match them. So I'll be back soon. I'll tell you guys what, now I'm starting to get off my ass and build all these projects that I've got. It's going to become really apparent why I have the component collection that I have in here. And you know, something you'll find as amusing as I do probably, as many components as I have, I still run out all the time and have to order stuff. It's amazing. I mean, I guess certain things you do just go through a lot of, like resistors and capacitors and transistors, you know. But yes, anyway, no, that's not the finished product. I am going to glue this and compress it. I don't want this to be moving in situ, vibrating and having its Q factor and inductance value changing. That would be terrible. I'll tell you what, it is really nice having the component collection I do have, because I had a look in my drawers and guess what I found? Okay, well that's not all I found. That's partially a lie. I found quite a few air core inductors, but for this purpose, these are the only two that I want to use out of this drawer. These are the right thickness of wire, but not enough turns. Yeah, so also, incidentally, I've decided to go with 12 turns. Wrapped around a AA battery as a former. That's what I'm using. Look, even this here, this comes out around 1 Henry to 1 Henry. God, 1 microhenry to 1.2 microhenries. You know, in series mode, in parallel mode, it comes out as, one second, bring my LCR meter over here for you guys. 1.6. You know, I don't want to make the coil that big, and look, to be honest with you, the reason why I'm going so big in it, I don't mean in the physical size of it, but I mean in terms of the inductor size, is because these are really powerful amps I'm building, and I'm going to throw lots of different loads at them, you know. I build speakers, I crank loud music, they're going to be driving huge speakers, some with different, you know, lengths of cable, different types of crossovers, different resistances. The speakers themselves will have different levels of inductance in their voice coils. You know, when you got that much power and you're going to be playing around with it, you know, with the loads, it's advisable to build a decent Zabel network, you know. So that's what I'm doing. From the view of keeping the amplifier loaded in that high frequency range, and from the view of what comes back in the speaker terminals, that's why I've gone with a fairly stout network here. I've gone with a 4.7 ohm metal oxide film, 2-watt resistor going to 100 nano 250 volt poly cap, and this is going to be 1.5-ish microhenries with a 4.7 ohm 5-watt resistor across it. So yeah, I'm trying to dampen out a lot, but you know, for a reason. So I'm just getting this other coil wound up now. I've got my battery here. I'll be back in a moment. I'm still winding this inductor, but you know what's making me laugh? I was just looking at these other two inductors on the table, and what, these are made from a manufacturer. Oh, I was going to say, it looks like they've done the same thing that I'm doing. Actually, that end's been squished, so is that. Hold on. They may just have. It's been bent in. No way. They did. I reckon that's what they did. Wouldn't be surprised. I mean, it depends if it was a out of a, you know, commercially manufactured device that was all made with factory parts, or if it was something that was built by hand. I can't remember what I got those inductors out of. You know, I don't have a clue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just double count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. I'll make that a bit short. So that's them. Yeah, you've got to be kidding me. Okay, what on earth did I do? Oh, you know what? It's 12 turns, not 15. I did nothing wrong. I just need to unwrap some of this. Oh, you know what? I got that dreadful feeling that I had cut it too short and was going to have to start all over again. I'll tell you what, it's always a good feeling when you realise that you made something too long, not too short. It's so much easier to fix the problem. So that's what we're looking for. Actually. No, that's still one turn too much. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What? I'm just going to pause and do this off camera because I'm trying to hold my hands under here away from where I am and it's just impossible. I need this under my face for a minute. Alright, so that is my coils wound. Obviously, I'm going to re-glue these ones where they've got a little bit of damage and my ones as well. So these will get glued and then, I don't know, I'll put something that's not going to damage the varnish and then put them in my vise overnight, you know, sandwiched like that. So they will be set in the morning. You know, 1.5 versus 1.75, which is incidentally what this come out to be. Yeah, it's just a little bit smaller. Anyway, so that's those sorted. So now, actually, I'm just going to clear my desk because for this next part, I actually need a bit of space on the bench. I just wanted to point something out whilst I'm getting my table ready here, because I actually meant to mention this before when I was discussing this section, because I'm sure some people wondered why I had just a straight line there, and even now there's only 2.2 ohms and 10 ohms for the base resistors on the drivers and the outputs. This is why, because I match everything. So if you're going to build an amplifier and you're not going to match everything, you might want higher resistances to balance things out. But because we're going to match everything from the drivers back, we can get away with lower resistances, which is obviously a better thing. So I'm doing all of this for quality reasons, right? But, you know, that's the thing with amplifier design. You're picking between something that's just really loud or for PA use or something like that, or you're trying to design something that's hi-fi and anywhere in between the two. And you've got to pick where you want to be and design in that area, if that makes sense. Anyway, I'm going to continue making some more room here because I want to put my matched transistors off to the side. We might get these done. I might get the tip 41 and 42s matched up now too. Incidentally, if anyone's noticed, these tip 41s and 2s that are off to the side that are from my old amp builds, these are not going to be used in this build. They're just there because I'm sorting through them and testing them. But I've got all new transistors for this build. The only transistors that I'm reusing are these small ones that are in the pre-driver buffer section, whatever you want to call it. I guess technically it's a buffer. So, no, pre-driver. I don't know. Haven't thought about that. Anyway, I've got space now, so we're going to get a start on this. I'm just going to set up a bit differently. Okay, the first thing I'm going to do, I've taken just from 3 random sections in each half, 3 5200s and 3 1943s. What I want to do is I want to get a general feel of where the beta is on each. So, and I'll get to why I'm doing that in a second. Oh yeah, that's right. That thing detects on first press. I always forget that. I'm used to the component testers that you turn on and then press test. 116. $106. $115. That's enough. I got a feeling that most of them are going to be around 115, and on the PNP side, these are the 1943s are going to be closer to 100, but we'll see. Oh wow, they're higher. Okay. Are they all like that? You know what? 151's a little bit high. I think I might pop a couple of these open, eh? These come in R, O, and Y, like the 3 categories for the HFE. These are only the O ones. That's right, I couldn't find it last time I was looking in the data sheet. I'm going to have another look and see what O should be. That's 148. The other one was, what, 155, 150? I can't remember. That's a bit high. Because the thing that worries me is I could quite easily find, you know, a transistor die that has 153, has a good 230 volt breakdown minimum, and, you know, a gain of 100, 150. Doesn't mean the die is going to be that big. It could be, you know, a little. It's not going to be really little. Well, it could. Yeah, it really could actually. So yeah, I think what I'm going to do is take one of each and pop them open. I think what I'll do is put that off to the side. I'll grab something to pick them up with. I'll get the hot air here. Go up to 480. I'll leave on 420, that should be enough. I was going to get them hot, and I'm going to take them over to the vise and put them in the vise and just, you know, crunch sideways. I don't like wasting parts, but I want to be sure before I go and build the entire thing, you know, find out the hard way, one way or another. Either during the build process, setting the fucking bias, or, you know, pumping the absolute shit out of it for it to go up in smoke, but I don't want that to happen. It sucks that we have to do these things in the world we live in these days. It would just be really good if people could just, you know, be honest. Not put shit online and sell it. I wonder how long this needs. Alright, I'm going to take this over to the vise now. Hopefully that helps me a little bit. Why did I do that? Jeez. Hopefully that helps me a bit. I'll be back in a sec. Beautiful. Couldn't ask for a better de-lidding. Wonderful. Wonderful, wonderful. Okay. Didn't want to drop all that on my floor. I caught it. Right. So we have, drum roll please. Ow. I didn't think that through, did I? Drum roll please. I'm already getting worried because I can't see copper. I'm pretty sure there's supposed to be a little bit of copper in here. And then the die sits on top of that. Ah, God. One moment. Oh, fuck. You gotta be kidding me. They are fucking fake. Oh, God. Fuck my life. Well, I'm glad I did that now. As soon as I saw that 150, I just said, nah. Not with O. You know, if these were marked Y, I might not have done that. But being as they're only O, like I said, they have R, O, and Y. That's not right. Bugger. Wonder if this is the same thing. I wonder if they all are that I got from different sellers. The reason I grabbed these is because these are the old ones and I really wanted to get my hands on them. You can't get them anymore. You can buy, I'll show you what I buy from DigiKey. When I get these from DigiKey, they come in this package. This is all they make now. This package is not made anymore. It's obsolete. These are A1943N and the other one's the C5200N. You can't get the 2SC 5200s and the 2SA 1943s anymore. So when I found people selling them for like 16 to 20 something dollars for a packet, with quite a lot in the packet, I was like, okay, I'll grab them. Well, at least I haven't wasted an incredible amount of money, but I still have to buy transistors. That's freaking hilarious. Sorry about swearing, but bastards. I wonder how many people have fitted this into an output section without having a look like I did first. That would not have ended well. That's not a TO92 die. Hold on, I'll come back to that in a minute. It's a bit bigger than the TO92 die, which is also basically the same size die you find in a lot of, I can't think what the package is. It's making my silicon move. I'm just trying to think what die that is. I can't think. It's about 2 millimeters by 2 millimeters. Yeah, 2 by 2. I mean, a TO92 die is like 1 millimeter by 1 millimeter basically. It's pretty small. That's a bit bigger than that, but that's definitely not a TO220 die, I don't think. TO220 dies are bigger than that. I'd expect a TO220 die to be more about 4 millimeters by 4 millimeters. Or at least 3 by 3. Around that region. I'm just going to take this over to the vise. I'll be back in a moment. I can already tell popping this open, it's the exact same deal because these are coming open way easier than a 2SC 5200 should come apart, and the reason for that is this is not the case that you find when you pop open a 2SC 5200. It's completely molded. There's no space in there. This has actually got an air pocket inside it, and the die, wow, that's even smaller. Jeez, that looks more like a TO92 die. That looks exactly like a TO92 die, and that looks like, I don't know where they've gotten these dies from. Well, there goes the output section getting populated this week. You know what? I'll go grab some of those other transistors and we'll have a look at them too. Right, well, let's get on to testing this. But you know what? That just gave me a good little thing to think about. I hope these tip 41s and tip 42s aren't fake, because I also found them cheap online and got them from the same place. Those of you that watched my component videos, when was it, last month sometime, I bought a whole ton of stuff off of AliExpress all around a couple of weeks time frame, and I tested a few things like capacitors and resistors and stuff like that. But the other thing I ordered a whole load of mixed components that were from I don't know, like just factory floor sweepings basically, and you could tell from looking at them that they were all legit components. These were the only semiconductor devices I actually ordered from some like random seller that was just selling a particular semiconductor. So if I've got fakes, it's going to be in these two drawers. These are separate, something else. It's going to be in these two drawers and these two drawers. So let's get to testing. And I'll make a video about this too with my finds, because, you know, I want people to know what's out there, of course. So I'll start with this seller first. And the reason why I'm going to start with this seller is because one lot of transistors from this seller has got the batch number 248. There it is. Now, we already know 248 was a scam. Let's see if it's the same 248 print. Yes. Oh no. Oh, hold on a minute. That's a slightly different package too. Do you reckon I might get lucky and some of them will be real? I'll be happy if some are, because I'm not annoyed about the fact that I've wasted money, because it wasn't that expensive. The thing that annoys me is that I can't build my amplifier when I want to. So if some of these are real, that would be really good, because at least I'll be able to continue with my work whilst I'm waiting for more real ones. I do have I've got plenty of other transistors, so we could always build a slightly less powerful amplifier output stage in the meantime too. So no matter what happens, we are still going to be building amplifiers. But anyway, well, I'm going to start with this 248 because, like I said, it's the same batch number as that. But if you look carefully, I'll show you when I take one of these out of the package. I guess this video is going to turn into a long video now. I was planning on just making a short little video with like just what I'm up to at the moment. But what I'm up to has changed a little bit. So I reckon these are going to be fake, because just after peeling the sticky tape off, it appears that the paint has lifted with it. Now, I'm not sure about that. That could be actually just like, you know, the sticky residue. No, I think that's coming off. We'll see if any black comes off too in a second. That looks like black to me. Why would black come off? That's something I've never been able to understand. Because the entire plastic's black. It's not like it's painted black. And this is laser etched. Well, you know what? That cleaned up good. That was just the sticky tape and dirt on top. I don't know if you can see, but that's not actually black. It's like a browny green colour. Okay. Well, that gives me a little bit of hope. Alright. That's really annoying, because I don't have a lot of these and I really don't want to go and break them. Let's see if we can work out a quantitative way of working out if they're hollow or something like that without popping them. Well, they sound the same. You know, I'm noticing the legs are even different. You see that? Look, I'll bring this up to the camera. So these two half moon circles are bigger than this device. And the legs, this is like a white silver, like a dull silver, and this is like a shiny silver. It looks like leaded solder and lead-free solder, but it's probably both lead-free solder, just different types, to be honest with you. But yeah, I mean, like I could literally just throw them, you know, away. I'm standing half a meter away, and I can still see the difference between them. I don't know how much that comes across on camera, but you know, I can literally just toss that in there. I can see that that's from there. There's quite a difference. So, not that I want to do this, but I can't think of any other way, and it sounds hollow, so I've got a bad feeling that these are all going to be fake. I guess I should just get on with it. I might hold this in the air and do it because my silicon mat is lifting in the center. It's gone back down, but I don't want to keep doing that. I don't want it to get stuck up in the air. Everything will roll off of it. Oh, goodness. Yeah, I've got plenty of other transistors we can use. I might even have transistors that are powerful enough and not need to use anything else. But the thing is, I will end up, even if I do, probably end up changing them back to these because I wanted to design the amp with these transistors. These are really, really good transistors for abusing. I have built a lot of different amplifiers and modified, I haven't built a lot of amplifiers, but I've modified amplifiers and built one. And I've used these devices in all of them. I've also owned some PA amplifiers that also had these in the output section. And I've never had a problem. And, you know, I've run 4 ohm stable amps at 2 ohms with these guys in them. Powering subwoofers. Going down as low as 25 hertz, 20 hertz, just ridiculous. You know, like I had a subsonic filter that was only 15 hertz and sometimes that was turned off. I'm a bit of a bass head. So these became my favourite transistors over the years because not only that, one thing I noticed when I was building my own amplifier is in the high frequency area these are pretty good too in terms of power dissipation, and they're just good transistors. They're quite indestructible. Alright, I'm just popping this open in the device. I'll be back in a sec. If this is real, I'm going to cry. Oh man, this is really hard to pop open. I hope this isn't real. You can't pop it open. Oh no, don't tell me. Oh fucking shit. You're not going to believe this. I just destroyed a legit device. Actually, hold on a minute. It's got the width, but wait a minute. Does it have the height? Hold on. Hold on a minute. Something doesn't add up here. No, wait a minute. That's really, really thin. I don't think that's right either, actually. But you know what? This is completely solid. This is, you know, I was showing you that other package and it's, I put it in the bin. Damn it. Man. That is the right side. It doesn't look right, but. Hold on. No, that's like glue over the top of it. That's not right. No, and there should be a copper heat spreader in here, shouldn't there? Hold on. This copper. Soft. Yeah, that's copper. Wait a minute. No, there wouldn't be glue over the top of it, would there? I don't know if you can see this on video, but this entire area, I don't know if it's glue or what it is actually. Hold on. I've never seen a transistor look like this inside, but so I think this is fake as well. They must just have different ways of doing them. Yeah, and I can now I've got some of this glue off. I can see the element structure of the silicon. You know how you see the little line. You can see the elements in there. They're very small. A normal device, you'd be able to see the lines would be way bigger. No, I'm going to say that's fake actually. I'm going to have to do some investigation into this because this is quite interesting. I'm just not sure if, you know, I don't know. It's got the width, but it doesn't have the thickness. That's confusing to me. I would imagine that you should see a bare copper color with the die on top of that, or maybe another little plate on top of the back plate. You know what I'm spewing? I just threw out a couple of these that were blown that I found in my drawers. I wish I still had them because I could pull them apart and have a look. Although, I'm going to pause the video and put the internet on my computer here. I'm going to connect the internet to my lab computer because it's not permanently connected in here. And have a look. I know where there's a picture of someone delidding original 2SC5200s. I'm going to go have a look at that picture because I haven't looked at it for a few years, and I'm going to refresh my memory and come back. Actually, I'll get it loaded up and we'll take a look at it together. Alright, so I've just been having a look at a couple of different places that I had a look at a few years ago when I was digging into fake output devices, and I haven't found inside a 5200, but I just saw this. And this made me laugh because I've never seen these devices in all black. I've actually got a crap ton of them right here. And as you can see, they're green and black. And you know, every time I've worked on an old amplifier that had these in them, they were green and black. Anyway, just thought that was funny. That's funny too. It's not funny when it happens to me. Anyway, yeah, I'm not having any luck finding inside die shots. I'm just going to check one more place. Give me 1 sec. Right, still not having much luck. I found this YouTube video of someone that's claiming that this is the real one. I kind of believe that, but the thing is, whilst mine looks the same as that, you see how it's got this glue looking area? Like, without pulling another one apart, it's going to be hard to explain this, but basically, actually maybe if I bring it right up to the camera, if I can get it to focus, there you go. So the die itself, and I'll just take a component leg here for comparison. If I take the leg of this, what is it, 247 device, the leg is thicker than the die, and that is definitely the top of the die, because I can see the top of the die and it's got this glue over the top of it. This entire area is covered in something. I don't understand that, because, oh no, it is glued, right. I get the two bond wires coming here. I get that. Maybe that glue is supposed to be there. You know, if you know, leave it in the comment section. I do have a couple of, what are these? 2SA 1943s. I mean, I could destroy them. They don't really have much pin on them. And one of the backs on one of them's corroded. They are good transistors, however. I don't know. I mean, that die's got to be, I don't even know what to say, 1/4 of a millimeter, if not less. I mean, it's about 3/4 of the height, half the height of a leg. Thickness, should I say, sorry? Yeah, it's only half the height of a leg, and a leg's only like, I don't even think that's half a mil. 1 sec. that hurt. Yeah. Oh no, that's half a mil. That's quarter of a mil. And that's half of a quarter of a mil. I can't even think. That's what, 1/8 of a centimetre. I mean, of a mil. 1/8 of a mil. Centimetre. It's getting late. I just can't see that being right. But the thing that blows my mind is the package looks... It's not plastic either. It's the proper... If I can get that on camera to focus... You see how it's got that shiny, sparkly texture to it? It's proper transistor plastic, not that other plastic that these are in, you know? You know what I think I might do? I think everyone knows how indestructible these are too. These are like my favourite old school transistors. The 1302s and the 3281s. These are like my favourite old school transistors. And these are my favourite newer school transistors. I think what I might do, if I've got enough here and they all match up nicely enough, I'll build both amps just with them. Because they're very similar in spec to the 5200s, but I think these might be a bit more rugged. That's what people claim. I have abused one amplifier that they were in, and it should have died and never did. So, yeah, it's possible, but like I said, I've used these for my abuse victims and they've never died. So, I mean, you know. Well, I don't know what to make of this now. I am bewildered. All of these cases are the smallest style of case. You know how before I was saying that the half moon circles are a bit smaller on this case. These are all smaller, so I don't want to pull any of them apart. However, I did notice these are all packs of 10. Now, I'm only going to be using 8 at a time. So I could go and delid one of each bunch, but, you know, I don't think there's a point in this case, unless these are just getting faked a different way. You know, like with a different case. That is quite a possibility. I'll leave that there for now, and I'll leave a bit of plastic with it. I'll go grab that other plastic too, just for reference, because that was just absolutely ridiculous. And another die. So far, we're going to get a little bit of a lineup going here. We've got that. You see the difference I'm talking about with the plastic. It's totally different plastic. Even if you look at the broken cross-sectional area. Focus. See, it's just shiny. That's what I'm used to seeing when I delid proper products. Not that I go around deliding proper products for the fun of it. Well, we've got 228s and 223s. 2 piles of 228 batch. Let's delid one of these. I just want to see if they all have the same sort of die, because you know how when we delided these, one die was, you know, like 1 mil square and the next die was 2 mil square, but they both had the same plastic. I want to see if these have the same plastic but different dies. Does that make sense? Because that will be a good indication that these are fake. I think they're fake. I can't see the die being that small, and I'm sure I've delided 5200s and 1943s before, and I'm sure the die is not that small, but I could be wrong. I could be wrong. It's been a while since I've actually taken a good look inside a transistor. I've got... It's a good point, actually. Hold on. I should have a couple of delided transistors just around here somewhere. Here they are. Yes, I do. One MJ15003. Now you see what I mean about the dye. You can see, you know. Sorry, I know that's not focusing too well, but hurry out, come on. Let me get a component leg and do this test. Oh, okay. Shit. You know what? This is real. You gotta be kidding me. Wow. Oh. No, it still is thinner. This is an old transistor butt, so I would imagine it to be thinner. I mean thicker. Bloody hell, that's got me scratching my head. I don't know what to say about that. To delid or not to delid is the question. I think I might not delid this. I think I might keep it for now. What I'm going to do, oh yeah, that came out of that. What I'm going to do is I'm going to keep these ones as they are for now. I'll populate an output section. What we'll do is we'll build an amplifier with each. We'll do 1 amp with the 1302s and the 3281s, and we'll do the other amplifier with the 5200s and 1943s. For now, that's what we're doing. Like I said, I've got plenty of transistors. There's no problem. You've seen I've got a heatsink with SAP 15s on it. I've got so many output transistors. Let's just leave it at that, you know. There's no problem with working out what we're going to use. It's just annoying. And these are not blown. These I did buy from a seller on like AliExpress or eBay, something like that. But these are original board pools. I don't know if you can tell. There's nothing wrong with them. I've tested them all. So that's, you know, that's a guaranteed build there. There's enough there to do 2 amplifiers if I have to anyway. Alright. Let's go back to matching. Let's throw that in the bin, put the other good half there. Alright. Let's try. I'll throw them in the bin. Do I want to delid these? Man, this sucks. This bloody sucks because I hate ruining parts, you know? Just for the sake of it, but the freaking dodgy shit people do, you know? I don't see anything inside that. Oh yeah, there is a letter in there. They do look real. I won't lie, I've bought these from Farnell and from ST. Well, that's the only 2 people I've actually... Why do I keep saying Farnell? Fairchild. That's the problem when you know too many brands. You just start blurting shit out wrong. It begins with the same letter, but it's not the same brand. I've got them from ST Micro and Fairchild before, and the Fairchild ones did have this dull looking plating on the legs and the package, and they did have this same package. In fact, give me a moment, I might still have some. I did have them around and I was wrong. It wasn't Fairchild, it was onsemi. But as you can see, ST and onsemi, and the onsemi have the exact same looking package in terms of the colour. You see how it's that whitish silver and the plastic's shiny plastic. So I don't know. This just sucks, you know, because I'm probably going to go delid these now and then they'll turn out to be real too. I don't know what to do here. You know what? I've got enough. I've got all of those from the cheap ones I got off AliExpress. And pretty much every single one in this pile here should be good. Plus probably half the ones on those 2 amplifiers on the bench, which is another 8. 4 PNP, 4 NPN. So I've got enough, I guess. Yeah. Screw it. Let's do it. Whatever. I don't want to, build an amplifier, load it up, and have bad things happen. And trust me, I am the sort of person to load it up. And I mean load it up. You guys will see what I'm like once they're built. There's a reason why I'm doing this. I'm the sort of fuck, they're fake. I know the size of die that goes in here, and that is not it. Jesus Christ. Really? Really, guys? I'm sure it's bigger than that. It's got to be bigger than that. It has to. I've deleted A1667s and, what are they called? Hold on one moment, please. A1667. What's the counterpart? I can't think. C4381Y. I've deleted them before, and the die is like twice the size of that. However, they are older transistors, but they're not as powerful as these, I don't think. You know what? I'll go through this pile quickly. Maybe it's been so many years since I was playing around with these amps. Who knows? I was just assuming that these are good because they're in a pile, but half of these look like they've been pulled out of something, so maybe they're blown. You've got to be kidding me. Oh, really? Because if I can find a blown one here, we'll delete that. I really don't want to delete genuine ST parts. Oh, that's a tip 42. Damn it. Thought I found one. Do these really have to all be good? I mean, I don't know why I'm complaining. You know what? They're all good. Bugger. I must have gone through these a couple of years ago already. That sucks. I don't know what to do now. You know what? Let's have a look on the amplifiers. I'm sure one of these has got to be fried. Get out of here. You're kidding me. You've got to be kidding me. Man, this is getting more annoying by the moment. I just want to know what's going on here. One moment, I've got to go get a tissue because my nose is running and I don't want to blow it on camera. Hey, you know what I just spotted in that pile? Tip 42 CG on semi. That's their highest voltage rating on CG. Look. I do have Fairchild one. It's missing its legs, but I do have one. We can compare. Interesting. You know what? That's got the shortest legs. I'll sacrifice it. I don't want to sacrifice good devices, but like I said, I don't want, fake shit. Let's have a look at this. Oh, it is actually supposed to be that small. You know what? I'm just used to older transistors, like the 15003s, the 1667s, the 4381s. You know, I'm just a bit old school like that. I'm used to my older components and my newer components. I guess die sizes have gotten narrower over the years. Technology's improved. Fair enough. Oh, didn't see that. All right, well, that settles that then, I guess. Wow. Yeah, they're both the same size die. Okay, so I guess all these are real, and these are real. We know these are real too. Sorry, I know you can't see them. So that's good news. I guess I only wasted about 30 bucks then, because this was either two $16 orders or one order that cost about 30, 40 bucks, something like that. I can't remember. Maybe it was two $30. I might have spent $60 on this. Oh well. It's not the worst thing, it's not the best thing. I mean, hey, I forgot about that. We've still got these ones. Knowing my luck, these will be fake. Yeah, they're the fake ones. That sucks. Might as well just delete it anyway, right? I'm really curious now what's going on with these things. The reason I say it's fake straight out the bag is because the legs have got that shiny solder on them. They're very dusty too, but that could just be because they're all in the bag, you know, like rubbing against each other in here. There's supposed to be 2 series of letters there. Anyway, I'm going to pop one of each open. Let's see what we get here. I'm 99% certain these are fake just because of the case style, but we'll have a look. You know the annoying thing about getting fake transistors in this big of a package? You can't use them for anything else. Like, the package is that bloody big. You know, say it's a really good die for RF amplification or something like that. You can't use it for that because of the freaking package. It's just, yeah. It's a pointless thing to do. I don't know why people do it. I mean, I know why they do it, to make money, but these guys can make money. The guys that sell the TIP 4142s are making money. They're not selling fakes, so why do these guys need to sell fakes? You know what I mean? Like, you don't have to do dodgy shit to people to make money. Alright, I'm going to take this over to the vise again and we'll see what we get. I'm pretty sure this is that hollow case. Only one way to find out. Ah, bloody hell, I broke my vise for this video. I put that much force on the handle, I bent the handle when I deleted the real one. Second vice I've done this too, true story. I should probably get bigger vices, but oh well. Lesson for next time. Buy a bigger vice. And the big reveal. Oh, you gotta be shitting me. That's the real one. What? With the shiny solder. And yeah, that glue stuff's over it. That's exactly the same. I de-lit it a bit different, so it sort of broke some of the plastic, but you can see that glue stuff underneath the plastic. It's the exact same construction. Should I do a 5200 as well? Might as well. I mean, I've got that many of them, eh? The amount of power I'm going to be running through these amps, you know, like that's the whole reason I'm doing this, you know. If this was a little 45 watt, you know, project that runs off of, you know, some small voltage or whatever, I probably wouldn't have done this. But being as this is two 500 watt amplifiers that run 4 amp loads, I want, you know, I want to be sure. All right. I'm really surprised about this. As soon as I saw the shiny legs, I said straight away, you all heard me. Fake. Fake. No. This looks different. I don't know what to say about this. I mean, I can't complain. I bought these with my money. So, the less that are fake, the better for me. But at the same time, I'm interested in this too because I like seeing stuff. You know, I just like to know what's going on. I'm just one of those curious people. I only give this heat for a bit longer like I did the first ones I de-litted because I rushed the latter ones and they were harder to pull apart. One broke my vice handle. I'll turn the temperature up a bit too. Oh, damn, it's down. That's up. Alright, temperature's up from 420 to 440. Airflow's been slightly moved from 4 to 5 in the last minute. In 2 increments. Alright, I'll be back in a sec. Shit. Alright. Another DVD, and it looks like a real one. Yeah. Okay, so that's good. That's well, so far, what, 4 packs? Not 4 packs, 1, 2, 3, 4, 5, 6 packs. If these are genuine from Japan, I'll be very happy. I'm still a little bit cautious. I'm still a little bit, I don't know, what you want to call it. I'm still a little bit unsure just because the die looks so thin, but from what I'm seeing now, deleting other devices, it looks like that could just be me. Look, if you're a little bit older, you know, like at least my age, I'm 33 in a week, you know, you've been around for a bit and you've deleted a lot of devices, not just one or two. Like, honestly, if you've deleted a few things, leave it in the comment section what your take on this is, because, you know, like as you can see, they're the right width, but just a little bit shallow in my opinion. But when I'm looking inside other devices, I'm seeing the same thing with the newer devices. So I'm wondering if that's just because I'm used to pulling apart old devices. I'm not used to pulling old devices apart. I'm used to buying stuff to replace an old device and pulling the part I've bought apart to make sure that it's an original part, if that makes sense. Obviously, I've replaced a lot of older things, so I've pulled apart some older parts. I haven't really pulled apart any new parts. Like the newest transistors I've ordered have all come from reputable sellers, you know, whether it's like DigiKey, Mouser, Jcar, whatever. I haven't had to pull them apart. So, yeah. All right, well, back to matching then, I guess. Jeez. I think what I'll do is I'll upload this video as it is, and then whilst that's uploading, I'll start matching transistors, and I'll make that video separate because this is already going to be over an hour long and I don't want to make it any longer than what it is for you guys. So I'll sign off here. Yeah, got nothing else to say. I'll see you on the next one. Thanks for watching, and please like and subscribe. And, you know, go down in the comment section, like I said, if you have got some input on this whole die conspiracy, I'm going to call it. Leave your thoughts. Like I said, on the thickness of the die, not the width of it, is what I'm concerned about. All right. See you all soon.